So I hope everyone's had a good evening so far. I'm here to present to you an app that I've been working on for the past year and a half or so that I hope will be of some interest to physics teachers. I'll get into it soon, but first a little bit about me. My name's Jack. I'm not a teacher, in fact I'm a student at the University of Canterbury, and first and foremost my field is programming. Within that field I enjoy working on projects that marry things that interest me. So I'd like to take the time to tell you about a project that I've been working on that brings together my passions for game development, physics, and education in a way that I hope can inspire and engage others. And that project is Goldberg Physics. So what is Goldberg Physics? I think the most important thing to start with is to say that in essence it's the same. It's the same concepts, questions, and methods that you've been teaching for years. And that's because Goldberg Physics has been built from the ground up with the Level 2 physics curriculum in mind. At its core, the game is just a list of practice questions, with solutions exactly like what you're seeing here. Everything built on top of that is there to make those questions more accessible and intuitive. But what is built on top of that core idea? What does Goldberg Physics do differently? Goldberg Physics aims to engage students by taking NCEA-style problems and turning them into levels in a game that are designed to test students on important topics. As I like to put it, this works to demystify physics. It takes it from being equations on a whiteboard, confusing and abstract, to something more intuitive and accessible in the form of a game. Through this gamification, Goldberg Physics provides students with a new incentive to learn. Complete every level, collect every star, get to the end, and in doing so, understand the things that you need to know to succeed. Progression and rewards make Goldberg Physics feel less like a stack of practice papers to work through, and more like a goal to work towards, something that students can achieve and feel proud of, knowing that they've learned along the way. The information in the game is represented visually. Everything a student needs to solve a problem is right there in front of them, and they can analyze what they need to do just by looking at the way the level's laid out. This is great for everyone, but it's especially useful for students who may not speak perfect English or that struggle with literacy. Goldberg Physics allows you to engage all students equally and lets you get down to the physics faster because of it. On top of all this, the app is designed to work on mobile devices, allowing students to study anywhere that they bring their phones, tablets, or touchscreen-enabled Tesla Roadsters. Students don't need to worry about bringing pages and worksheets with them to study. 5 minutes in the car is all they need to sneak in a practice problem. Since the app's designed to be used in schools, it's important to me to design with education in mind. One of the things that I see more and more schools doing is bringing technology into learning, which is great, but without the right tools, this can sometimes feel like a step backwards. Goldberg Physics takes full advantage of the digital medium and brings something new to the table instead of just replicating more traditional tools. The app's available on Mac, PC, Android, and iOS, meaning that all students have a way of accessing it. And since, at its core, it's still just a list of practice questions, you won't be jumping through hoops to find ways to make it relevant to your lessons. As an additional tool, a worked answer sheet has been made available on the project's website to help you help students more quickly. And as I continue to develop the app, more teacher-friendly tools will become available. One of my next key steps is to add a system that allows teachers to see how their students are doing within the app and where they might be struggling. So really, calling Goldberg Physics a game doesn't do it justice. It's dressed up like one, sure, but what it really is an interactive learning tool. Students can literally reach out and touch the mathematics behind any question they get, and they can see how different values affect how the level plays out. I also feel like the word game implies some level of abstraction from reality, like the product is some sort of imitation of the curriculum, and that by taking that core curriculum and building visuals and gamification on top of it, we also must be sacrificing some part of what we started with. But I don't think that's the case at all. In fact, I think that by making physics tangible and reactive, we bring it closer to reality. For many students, Level 2 physics is their first real look at the way that they can analyze the world around them using rules, making sense of things that they've been seeing their entire lives. So why do we start them on this journey? By abstracting the world into a form that we can put on a whiteboard or print on a worksheet. Everything we know about mechanics is derived from the way things move in reality. By giving students a tool that allows them to see this relationship, we give them a better idea of what physics as a whole is about. It's not just another maths class, it's about understanding movements and interactions, things that we see in the real world all the time. Goldberg Physics simulates a world in which these movements can be analysed, using only what is taught in level 2, stripping away the complicated while maintaining that sense of observation and realness. In a student's mind, a universe in motion begins as that, in motion. Physicists are not inspired by the formulas that they learned in high school. They're inspired by seeing where those formulas come from, by the notion that somewhere in the chaos there are answers to be found. Goldberg Physics lets students see how they can apply those answers to problems such as the one that they will come across in their exams. I have no special talent. I am only passionately curious. No student enters their first physics class with a complete understanding of the intricacies of the universe. But if you'd like to help them expand not only their knowledge, but their curiosity about where that knowledge comes from, take a look at Goldberg Physics and help us extend our passion for passionate curiosity. Thank you.